In the last blog, I mentioned training stress balance as a very nice and simple way to analyze your time series data. Any type of loading, might be heart rate variability, might be GPS, might be session RPE. And in this video, I'm going to demonstrate a simple way how to do it in Excel and kind of discuss two different ways and pros and cons of each. Again, I'm not expert on this, and if you feel I missed something or I need to be corrected, please be free to do it on the forum. So anyway, we have a couple of columns here. The first one that's most important is load. In this case, just arbitrary units, just for sake of example. On each day we have quantification of training load, and Saturday and Sunday are off. We have around 100 metrics, around 100. My computer is going slow, I don't know why. I'm running Microsoft Windows in parallel to Mac. So anyway, on both charts you can see blue bars as this particular training load. And chronic load, in this case I selected 42 days. If you click on a 42, or let's say 40, and click on a formula, it takes the previous 42 days and average across. And since it's a rolling average, if you scroll down, let's say this particular cell, it's gonna basically, the window is gonna be rolling. So we have 42 cells and they keep rolling downward. What happens if you're on a day that's shorter than 42? Then the rolling window is shorter. What you can do is basically disregard the data points that are below 42 or any other given time constant. But this means you basically need to accumulate 42 days of training load to actually start the analysis. So that's maybe a third option. Acute training load is same thing, just use a shorter time period, in this case 7 days. It can be shorter or longer, and we average across last 7 days. Again, it's a rolling window. If you go down in a downward cell, you'll see that the rolling window moved. In this first window, in this first chart, we can see the green is acute. And as you can see, the line is more to react to the acute changes in a training load, while the red one is a chronic and kind of represent the baseline. What we are looking for in this particular case is comparison between green or acute and chronic. So where acute is going over chronic, that means the loading it's quite rapid, and athlete might suffer, again depending on a magnitude, athlete might suffer from fatigue related symptoms like DOMS or adaptive stiffness, if Charlie Francis used to call it, or probably injury, maybe injury, depends if this is too high or just increasing load too quickly. Again, there's no right or wrong. This is more art than a science. Again, depends on those time constants you choose, but it gives you a quick indication what's happening to a load compared to this a simple bar graph. At least you gain some insight like what's happening to load. In this case, for example, if you check the green one, the load is below the common loading. So you might expect a couple of things. You might expect tapering, so athlete might increase in performance. Or if this continues and it affects the chronic load, so the chronic load starts falling down, then you might expect detraining and loss of specific work capacity. So in this particular case, we used average across And in another case, we're going to use sum and divide it by 42. As you can see, so this another chart is basically same loading on a blue bar, and we are visualizing chronic and acute, in this case using slightly different metric. So we are summarizing and dividing by 42. After 42nd day, in this case for chronic, the graphs are the same. So the graphs are the same. Same thing for a green after a 7th day. So as you can see, the green line is pretty much, it's actually the same as the top one, except for the first 7 days and first 42 days for the chronic. This might seem like a bad solution, but I'll quickly explain you why it might not be the case. As you can see, it takes maybe 42 days to accumulate the training load, so you can accumulate the training data. Again, you might disregard the first 42 days and then just starting calculating the chronic and acute after 42, or you can just kind of squeeze the rolling window so it fits the start of your data collection. Again, more art than a science. One thing I'm going to cover in the next blog post is basically each model have a lot of assumptions, and unless you understand the assumptions, you might make wrong conclusions from the data and from the model. In this case, the first model assumes that on each day you're going to have a particular value. So in this case, days off are coded as 0. So that means that the load is 0. That might not happen all the time, and sometimes the coaches might forget to enter the data, or athletes enter the data for a days off. And sometimes you just want to, you don't want to kind of make athletes enter the data on their days off. They just want to be, with the families and, not opening their phones. Again, depends on the culture you have in your particular case. And the problem with the first method is it's not robust. It's not robust to lack of data or missing values. So in this case, if these two are deleted and you will see the training load will increase. And if you go backward in this video, you'll see that the top graph is increasing, but the bottom one is not. I'll just continue putting zeros. So you'll see the top one is increasing, but the bottom one is not reacting. So that means that the bottom method is more robust to missing data, because we are basically summarizing and dividing by 42, that 42 days. So if the data is the same, the models will be the same, because averaging is basically summarizing and dividing by 42. But if you miss the data, especially the days off, we're gonna count those as 0. So the days will be counted, but data, since it's empty, won't affect the average. In the top scenario, when we use average function, missing data will affect the the calculation. As you can see, it will increase. There's another thing that will affect the calculation of chronic and acute is double sessions. So for example, if you have double sessions, just using average will again will affect the way the data is calculated. So if you have double sessions and using average across last 7 days, for example, in a Smartbase or any other software, it's not going to take the summary of the daily load. It's going to take the average of each session. So again, it's not robust. It's very fragile method in calculating, reacting or actually taking into account double sessions. So in this particular case, and in my opinion, and thanks to Kirill Wannberg from Fusion Sport for giving me a hint for this, is this might be more robust to these problems, missing data and double sessions. So basically just take the sum, divide by 42 in a chronic, or in this case you take the sum and divide by 7. Again, that's going to work better and will be less fragile to missing data, and that's going to happen a lot. Anyway, the point of this talk is that we cannot just take any graph or any analysis for granted without knowing the underlying assumptions and underlying, how the data is summarized or how the data is calculated, especially for aggregated data. So that means that the data is basically aggregated from multiple days or multiple sequences. So we need to know assumptions behind it and how it's calculated to basically make any predictive claims. And if you've been studying statistics, it's quite similar for any modeling in regression and making inferences to a population. There are certain assumptions of normality, of homoscedasticity. That's a dangerous word, and so forth. So basically, assumptions needs to be made for the first model to work correctly. There shouldn't be missing data, and for the days off actually needs to be coded as 0. And for the second model, that can be kind of overcome by using the sum and divide. But as you can see, it affects the first 42 days, and you can see that. So basically, you cannot make any judgments about the first 42 days because the baseline is kind of building up, while in the top one we can reach or calculate the baseline quicker, and we can start using the data a bit quicker compared to the bottom one. Again, pros and cons of each one. Thanks for listening, and see you soon.